The following video discusses how Indigenous knowledges and AI can create opportunities in education to understand important concepts such as sustainability, as well as our roles and responsibilities with respect to the environment. How does this project help to understand concepts found within Indigenous knowledge systems?
As a Hongkong person, we've talked about for years our sustainability throughout all four seasons and our relationship, not just to the land, but to the water, to the animals, and to the trees. And so, even in our language, it encompasses that. And to actually have students come out to do what is now land based theory, it is a challenge. So, we're talking, but they're not getting it. So, we needed aids, we needed help. So, when this project came up, would you be willing to work with AI? And the very first thing is what's it going to do? How is it going to help us? To sit here and see this thing, it really opens up your mind and your imagination. Now, this might hook the students. Oh, that's what it's like. Yeah. Everything that my father ever talked about our people through all four seasons is now starting to come to life. It's making sense. So with this teaching tool, and that's what it is, it's a tool. It's not going to erase anything. It's not going to erase us from going outside and to living that experience. It is going to help us and aid in going through. So this is where the balance comes in. With the scientific mind, I'm able to put in the cultural components in there, and it is really helping. And each and every time we met, it starts to expand. It started getting bigger, and we keep adding on. This tool is going to be so amazing that students in any grade are going to be able to now understand Indigenous sustainability throughout all four seasons.
How did this simulation come about, and how did the AI come to determine that sustainability is the best outcome on its own?
This whole project and collaboration has been very interesting because even for myself, it's not completely obvious from the outset how we can bridge the world that I'm used to, which is this world of artificial intelligence and computer science, and how we can bridge that with these Indigenous knowledge systems. But by working with this group and with Ray, connections start getting made, even for myself, that I find very interesting. So how this project kind of came about is, at least for this portion of it, is that we knew we wanted to do something with a specific modality of machine learning called reinforcement learning. So this is a pretty intuitive process where our AI models are given a reward when they perform an action that we like, and then they receive maybe a punishment when it's something we don't want. You can think about this like maybe touching a hot stove or something, where after you touch it, that's a negative feedback that you receive, and you know not to do it again. So in this case, what we started with is, okay, there's ideas of we're looking at sustainability and making sure we're not over harvesting the land. These are seeming like core principles of Indigenous knowledge systems. So what we built is an environment where we have two AIs, these two little robots here, and one of the robots is really good at farming. This is the green one here. And then we have this blue one here who's really good at fishing, okay? And then on their little world they have here, they have areas where they can fish and areas where they can harvest crop. And if the fishing robot tries to harvest crop, it can do it. It's just not that great at it. It won't get the most yield from the land. Same thing for the farming robot. If it can farm very well and get the most yield, but if it tries to fish, it's not that good at it. And what we told these AIs to do is one thing and one thing only. They're rewarded for surviving. So it's important that we stress that we're not trying to lead the AI with these indigenous knowledge systems. We're saying, no, just live, survive for as long as you can. So if either one of these AI run out of food or run out of crop, they will die. And then the simulation ends. And what we found is that the AIs are told to basically optimize whatever strategy will lead to their survival. And the first thing they learned how to do was okay, the farmer would farm as much as he could because he's good at it. The fisher would fish as much as he could because those are the roles that they're getting the most yield out of. But we added one more component to that, which is this little trading post here. This trading post allows the AI to, let's say, give a crop and take a fish, or give a fish and take a crop. And what the AIs learn to do is, without even knowing that the other one exists, they are using the trading post. When there's too much crop from the farmer, he gives some up and he takes some fish. And the exact opposite for the fisher. When it has too many fish, it will give some to the trading post and will take some crop. And I'll maybe run the simulation here. You'll see that these two AI, right? And let's look at it on this screen here, right? You can see there how many fish and crop the respective one has, and they'll first of all not only learn to not overuse the resources on the land, because once you deplete all the fish or all the crop from an area, they won't come back. So not only do they learn to migrate to other areas when they've fished too much or farmed too much, but they've also learned to cooperate and share resources with one another. And the key thing to stress here is that all of this behavior is emergent. We did not tell the AI to do any of this. We can see a perfect example. The fisher just switched location because this area was getting too low. I suspect the farmer will do so soon as well. That they learned to share the land. They learned not to overconsume. They learned to do all these things because it's actually the best thing to do. In their world, this is the best way to survive. And it just kind of reinforces a lot of these indigenous knowledge principles that we have. So that was really great to see that we did successfully bridge that gap, and we did so in like a very genuine way.
So on our side, when I see this, any knowledge shares should say, okay, that to me is the dish of the one spoon. Exactly why they created that wampum belt, that we're over-consuming something. But it was between two nations, Anishinaabe and Haudenosaunee. They came to a mutual agreement that in any area where we are hunting, we need to share. And that there, exactly what we instilled in there is showing us. These are two different bodies of being. It's the same thing in that dish with one spoon. So now when we talk about this in the classes, they can actually see that these mechanical beings are able to do that. What is wrong with the humans? When we say that, how come they can't do that? We're saying it for years and years and years, and here within a little bit, these two little beings on their own little pieces of land can coexist. And what Mathias said, they didn't even meet, but here they are coming together because they know that either side of on that land they need to coexist. In the end, we want to influence the younger students about Indigenous perspectives of what we've been talking about for thousands and thousands of years. And now you get a chance to see it with something that you're familiar with in using computers and games. There's so many more things that we can touch upon just using this, and it's open now. So they're having a perspective. on Haudenosaunee life. And now it's open for Anishinaabe, for Cree, for the Innu, for the people down in the south. It is so great to see this. And I hope it influences people to come forward to share and put their input into this.
Why is it so important to work in partnership with Indigenous peoples and communities?
This is what reconciliation is about. It's about uh, learning from other people of what they have, their strengths, and that how does that help us? This is helping us in the education way, and it will also help us later on that maybe the students will get influenced by this and wanting to do it more in a physical way. So we need to create these relationships at all times. We need to see where it goes. There was a comment about how things are done. I remember my father would say that how do we know this would work if we don't try something? He was never afraid to try something. So when we're proposed with this, look at it and get used to it. How does it operate? And they always that backline. How is this going to help us? So we never shoot anything away. We always did that, and that's what a lot of the early ancestors did when there was something new, such as an axe or a bowl or a spoon or a fork. They would look at it and find different ways of how this tool was going to help them. So that is how you create these awarenesses, build these bridges. And then again, I was very reluctant at first, but when I got to see it actually in front of me of how it worked, I really started to see where we can go with this project. In the beginning, it didn't look anything until what we see in front of us right now. Now we're at a point where we're starting to add things. We're adding seasons. We're adding animals. We're adding different parts of anything in there, and it is really remarkable. Again, there's an opportunity here, trying to embrace it and see where it goes.
Walk us through how this project came to be from where it started as an idea to how it looks today.
Yeah, so I think the key thing I want to stress here, and this is now from a purely technical standpoint, is this is what is really important about designing systems that are flexible and modular, because when you're in these prototyping stages, you don't really know where the project is going to go, or especially when you're collaborating with other people, when they see the work that you've done, they're going to get new ideas, and the whole project can shift pretty rapidly and radically in new directions. So it's very important that whatever you're working on designing is that it's really modular. So this means when we're designing code or we're building environments, that we leave as many possibilities open as we can, and we try not to lock ourselves into really rigid code structures or um, things like that, where if we come up with these new ideas, it's going to be a lot more work, almost to the point where we're better off re-implementing something from the ground up. And a lot of this is done in the prototyping stage to even if you do have to get rid of something, you have to say like, that's okay. At least I didn't sink that much time into it. So when we look at environments like the one we built here, I didn't start with making it necessarily look pretty. I started with, okay, let's just build it with basic cubes and just lay things down. Let's not worry about having little robots run around. We'll just deal with primitive shapes. And is it is it acting like how I'm expecting it to act? Is it doing everything we want it to do? And once the project starts to shape up more, we can worry about these less important external things, like, does the environment look pretty? How about these little icons for the fish and crop, right? These are all things that you can do later once you have a better idea of where the process is going. In the meantime, if you're developing software like this. Don't focus on those things and just deal with little numbers being printed to the screen somewhere else that represent these things, because for all you know, you might not need that in the future. So that's my biggest takeaway, I guess.
What is happening behind the scenes from a computer programming perspective?
There's actually quite a bit going on here, and it's going to get into a little bit of the machine learning stuff, but that will be kept at mostly a pretty high level. Is that when we build environments like this, we have to realize that the machines have no idea what task they're even performing, or even what their environment looks like necessarily. So these two little robots here are just collecting numbers on the state of their environment, so they know their current position. That's a 2-number coordinate system. They know the positions of where they can fish. Again, a couple more coordinates for those. They know how many fish they have. They know how many crop they have. But when you really look at all the information that the computer has, these little AIs have, it's really just a list of a handful of numbers. We have the benefit of seeing this environment, and we understand the higher level representations here, but they don't. So we start by building this environment, collecting these numbers, but then we have to pass it off to these machine learning algorithms, which I train them in a completely different language than I write this software in. This is, to be technical, this is the Unity game engine, so it uses the C# programming language. But a lot of machine learning is done in something like Python. So I have to translate this environment over to a Python script, which will train for hours and hours, sometimes days, until it trains what's called a policy, which is how these agents should act in their environment. A lot of times it doesn't work. We have to maybe look at the reward structure. We have to maybe look at our network architecture. So when we say network architecture, we mean the neural network or the brains that these AI are using. Maybe it's not big enough. Maybe we're using the wrong activation functions. So there's a lot of tuning that goes into getting these agents to actually start working in their environment. Even in training, there's lots of different reinforcement algorithms that you could use. So there's a lot of just getting that to work, but it's really rewarding when it all starts coming together and the project really starts taking shape, and we can then start focusing on, making it look presentable to people.
What is the next simulation you're working on?
The purpose of this simulation here is we want to look at providing information about different animals. So we have this little simulation where you're riding on this little river, you'll encounter different animals out in the wild, and when you zoom into them, right, Ray will come up and he'll give you information about these animals. And the point is that we can travel through different seasons, we can get different information on all these animals and the practices that the indigenous people have, the relationship with these animals and with these seasons. And we can have this infinite little boat ride where we can experience all these things. And then from the AI point of view, we're going to integrate later some form of imitation learning. So this is where an AI can look at the actions a person's taking and can learn to copy them or imitate them. Currently, we're focused on the actual simulation point of it, and the integration with that can come later. But for now, we have this nice little environment where you can look around. If you see some animals, you can zoom in and take a picture of them. and then Ray will tell you about them. We're adding currently spoken word passages and dialogue. So if you zoom into something, let's say like this tree here.
Wahda is our word for maple, but it also pertains to the tree, hard maple. These are the trees that we tap.
Right, and the simulation will pause while you have that, and then you can continue. And this will go forever, and we'll cycle through all the seasons. The time of day will change as well along with that, and that's the main part of what we're building here.
Can you share some of the challenges you experienced in the design process of this next simulation you are working on?
In this demo here, when it comes to the design process and specifically kind of the prototyping process, it's very important that you don't overcommit or overwork on something that we don't know everybody necessarily wants yet. So when you're collaborating with people and working with people, there's going to be times where you think in your head that this is the way the project should go, but then the people you're working with get a completely different idea, and you'll have to backtrack on a lot of these things. So I'm going to maybe, as an example, run this demo for just a little bit, and give an example of when this demo first started. You would only have this first little area that you could play with and see what's going on. So we got a pretty decent idea. I didn't start with building the whole environment from the beginning, because if we wanted to take the project in a completely different direction, I would have done a lot of work that now I'm going to have to get rid of. It was only after we played with this for a little bit and we came up with ideas, we said, okay, yeah, I think we can support this environment, that I decided to then weeks later finish everything that is here. So now we go from having the demo used to end around here, but now we have this entire little loop here that we could go around. So before, the demo used to be only about half this big, and then I doubled on the size later. So that's the first thing of just kind of managing your scope and building what we call a vertical slice. So the difference being, if you build a horizontal slice, you build everything with very few features. But I prefer a vertical slice approach where I have almost all of the features in a very limited capacity. So in this case, we have the little boat moving. We have the ability to move the camera around, look at animals, take pictures of them, have dialogue. All the features we think we want are going to be in already. Just little things like the environment isn't completely done. All the animals aren't in yet. All the dialogue isn't recorded. All the audio. That stuff can be done later. But we need these other systems in place first to even support that. So that's the first approach that I like to take to that, is building what we call a vertical slice. The next thing is, and this is one of the challenges, is things when you're budgeting time for yourself, things that you think won't take a lot of time end up taking a lot more than you expect. So originally, as a part of my vertical slice, I had the ability to change seasons with this, what's called the material here, where we can transition from summer into fall. I thought extending this to all 4 seasons like we have now, fall into winter and then winter into spring, which transitions back into summer, I thought this process would be a lot simpler. To show you what this actually looks like in the code, the shader, the thing that powers these graphics, used to be about this big. And this is how big it was to power 2 seasons. But for me to get up to working with 4 seasons, I now have this giant complex graph where we're taking different textures and what's the value of this range slider, and we have to start blending between two and doing multiplications and additions and comparing against other values. And there's a lot going on here that even I didn't anticipate would have to happen to make this to extend this from 2 seasons to 4 seasons. But it works, and there are some things you just won't be able to anticipate, so I try to save time where I can. And that's building systems that are as modular as I can make them. A good example of this, though, where I did save a lot of time, was when we have to display dialogue and audio. And this is a great example, because we wanted a system where when someone explains something and there's text on screen, we want audio to accompany that. So I already had these little dialogue objects which contain both the dialogue that we want said, but also a little audio clip that ticks along as every character comes on screen. I very quickly can make basically a new one whenever I want. So if we can create a new dialogue object, and we can now make this for any animal that we want. We want it for a fish, right? And we go into our fish, and we can now set all these things up with as much dialogue as we want. And it's that easy to put something new into the game for it to use. That's great. So I did that with our newest object, which is a tree. So we can look at a tree in the game, and we now have this text come up. But now the audio needs to be different, because now we have spoken word passages from our Carly Gray. So all I had to do in my code to accommodate this was I just removed this 2 little lines of code here, and I just moved another line of code up here. And now we've transitioned from these little 1 character tick sound effects up to full spoken word passages by just jumping 1 line of code up. So that's an example of having a well-designed modular system in place where you don't need to do much to now take whatever audio clip I have here, and maybe I'll actually play the audio clip so we can see them, and hopefully we can hear them.
Wada is our word for maple,
Can we
but
hear
it
that?
also pertains to the tree,
Great.
hard maple. These are the trees that we tap.
Right, so we have these longer audio clips like this.
Dewa, Neeslux.
But originally,
Neeslux.
we had just little bloops like this.
Dewa.
Right? That's what would happen when like a little character would come on screen. Or like a single letter. But now we adapted it to full spoken word passages. And we're doing that with the same dialogue objects that we had, right? So when it comes to building these objects, it's good that we have these systems in place, but do expect that sometimes changes will be more complicated.
What programs are you using in creating these demos?
All the demos that I'm building are using the Unity game engine, which is nice because it's a platform that is pretty flexible in terms of what platforms it can support. So it can build for Windows, mobile platforms. It can also build for web platforms. So it's pretty flexible that way. But also because we are doing some machine learning and some AI-based methods like this, we can integrate them directly into the engine itself. So not every game engine you come across will have support for these things, but luckily Unity does have a number of tools that lets us embed these models directly into the applications that we're building.
Can AI be of benefit when exploring and understanding what Indigenous knowledge systems are also telling us?
I definitely do. I think examples like this definitely make a lot of these concepts more approachable. I think right now we see um, a lot of other uses for AI, which are equally valid, but there's a lot of worries about um, I don't know, like look at something like ChatGPT or something, where people are worried about, okay, well, what does this mean for my job in whatever sector? Um, but I think here it's like this is a pretty innocent application where it's pretty intuitive, easy to pick things up. Um, a lot of the concepts can be conveyed in a way that's understandable for people, even like outside of the field, and they show you some pretty unique and what I think are helpful use cases for AI. So in one of our other projects, we have it showing off, okay, well, these two are cooperating, or here's a use case for an AI that learns to plant trees. Here, this one is what's going to hopefully be an application for um, like an AI based, almost like a small little assistant that when you're out here taking pictures of these animals, that it will learn from your actions, and it can learn your preferences as to what kind of animals you want to take pictures of, and will help guide you in doing that. So I definitely think it's definitely a very approachable and honestly very exciting time for AI and all these systems. And I'm glad to see that more people and more communities are starting to look at the positive side of these things, because I think that's important too.
As a computer scientist, what has been your experience so far with this project?
Coming into this project, I was already pretty comfortable using a lot of these tools. I'm an AI-based researcher. I work with these game engines a lot. So on that aspect of things, it's been kind of what I've been used to. But in terms of the collaboration, that's where it's really something more new for me. Um, and that's been very for not just like personally, because I don't come from an indigenous background, so I don't know a lot of these value systems. So learning that personally is great, but then also from a professional standpoint, it's been really good working with this community, and it's been really challenging trying to bridge some of these gaps between um, these indigenous knowledge systems and AI. But the longer I work on it, it's becoming easier. I'm starting to see a lot more. Well, oh yeah, this would be a great application for imitation learning, or oh, we should use supervised learning here. Yeah, that makes sense. Um, and so that's been not only challenging but also very fulfilling when we start building a prototype and we're getting good feedback, and people seem to be responding to it well. Definitely the main thing is just the ability to, because when you're definitely as like a researcher in this field, you're really working just by yourself a lot of time, or if you're working with other people, they are also other AI researchers, and everyone's very like-minded on whatever project you're working on. My biggest takeaway from here though is when you work with other people and you start picking up other perspectives of things, it can be a very cohesive process where even though you have two people who are coming from seemingly I hesitate to say opposite viewpoints, but in a lot of ways you kind of are, but how you still, it's a very collaborative process that I think ends up giving you a better product or a better finished result than I think you would achieve working with just very like-minded people or by yourself.